Hi guys. Okay. Today, this is the second time for the mathematical induction. So then what I will do is mathematical induction again. About the trigo, complex, and derivative things. Today I will show you, I think, a few examples about those trigonometry, mathematical induction question, complex number mathematical induction question, and derivative mathematical induction questions, or about the mathematical inductions. The first example can be from this one. Okay, the first question is using mathematical induction prove that blah blah goes to be blah blah. This is combination between the the trigo and then the derivative induction question, right? As I said last time, the first step is to set the statement. Pn is the n times the derivative of cosine x goes to be cosine x plus n pi over 2. Then when n goes to be 1, your left hand side goes to be dx of cosine x, which is actually negative sine x. Your right hand side goes to be cosine of x plus pi over 2. Of course, you can immediately write down here the answer minus sine x, but that's what you need to prove, right? So that the better you can use to compound angle formula. Cosine a plus b is cosine a cosine b minus sine a sine b, right? Then we know that cosine pi over 2 goes to be 0, sine pi over 2 goes to be 1. That's why the answer goes to be negative sine x. Both are the same. Since your left hand side and right hand side are going to be the same, that's why P1 is true. Then next step is assuming that it's always like that. Okay, assuming that pk is true, which means k times of derivative of cosine x goes to be cosine x plus k pi over 2. Is it? Yes, correct. We assume this is true, right? After that, to prove pk plus 1, that is the next step, right? We start from the left hand side, which is k plus first time derivative of cosine x, which means that is the key. Yeah, this is the key step for the derivative induction. K plus first time derivative of cosine x means that there is one more step, derivative of k derivative of cosine x, right? And then this much is exactly the same with this thing, so that we can bring this in. Then derivative of cosine of x plus n pi over 2, and then the derivative of cosine x is minus sine x plus n pi over 2. That's alright. Now how we can change this sine into cosine? Minus sine of, no, sorry, minus, we must change this into the cosine of x plus blah blah, right? How? Negative sine a is same with what? Cosine a plus pi over 2. That's what we have proven in 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 this step, right? Here. Minus sine something is cosine of something plus pi over 2. We have proven this. So that we can change this cosine of this entire thing. No, not nk, sorry. K pi plus half pi, which is cosine of x plus half k plus 1 pi, which is your right hand side of pk plus 1. Right? That's why we can say that pk plus 1 is also true. And then you can say consequently, blah blah blah. You should write the conclusion, which you can refer to my previous YouTube. Right? So the key step here is, okay, we do one more derivative of the left hand side of pk. K derivative is k plus first time derivative of fx, right? That is the key. dx of f of n of k x. Yeah, putting this inside is the key, I think. Okay. Okay. The second example of today is a bit more complicated thing about the the trigonometry. Yeah, there's this one. The question is proved by induction that blah blah. So again the same. The first step is P. Let Pn to be cosine x plus cosine 3x plus cosine of 5x plus blah 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 plus, sorry, it happens again, plus cosine 2n minus 1x goes to be sine of 2nx over 2 sine x. And when n is 1, that's the next step, right? Your left hand side is just cosine x, and then your right hand side goes to be sine of 2 times 1 times x over 2 sine x, which is sine 2x, which is 2 sine x, cosine x divided by 2 sine x. And then you cancel 2 sine x, and then there is cosine x. So that your left hand side and your right hand side will be the same. So P1 is true. Up to here is easy. Okay, the next step is just remembering this step, and then copy all the things, right? PK is true. Then your PK left hand side is what? Cosine x plus cosine 3x plus cosine of 5x plus blah 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 plus cosine of 2k minus 1x goes to be sine of 2kx over 2 sine x. This is true. We assume that this is true, right? Then, to prove pk plus 1 is also true, then the left hand side of pk plus 1 is cosine x plus cosine 3x plus blah 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 plus cosine of 2k minus 1 of x plus one more. What is that? Cosine of 2k plus 1 minus 1 x, right? And then what we know is up to here is exactly the same with this one, right? So that instead of left hand side, yeah, we just copy the right hand side of the previous our assumption, which is sine of 2kx over 2 sine x, and then plus the other term is cosine of 2k plus 2 minus 1, which is 2k plus 1, right? 2k plus 1 of x. And then what we need to reach at the end is 2 sine x, and then on top sine of 2 of k plus 1 x. That is our goal to achieve, right? On the right hand side. Okay. Then anyway, on our denominator, this is proving process. So it's the kind of the easiest question in the world. Why? They show the question is showing the answer. In the answer, yeah, we need to have 2 sine x on our denominator so that we do go for the single fraction step, sine 2 sine x, and then the first one is sine 2kx plus the second term is 2 sine x times cosine of 2k plus 1x. Here what we need to have is a so-called trigonometric identity, right? What's that? See? Sine a plus b is what? Is sine a cosine b plus cosine a sine b, right? And then sine a minus b is sine a. Oops, again. Goes to sine a cosine b minus cosine a sine b. Cosine a plus b goes to b cosine a cosine b minus sine a sine b. Cosine a minus b goes to cosine a cosine b plus sine a sine b, right? Let's say this is 1, this is 2, this is 3, and this is 4. If you add 1 and 2, then cosine a sine b cancel each other, so that 2 times 2 times sine a cosine b goes to sine a plus b plus sine a minus b. In the question, what we have is sine times cosine, right? 2 times sine times cosine. Then the result goes to be sine a plus b plus sine a minus b. Okay, we use this formula. This is so-called the product to sum. Of course, there are three more identities like uh, 2 cosine A sine B, 2 cosine A cosine B, 2 sine A sine B. Yeah, those three more formulas are there, but what we need to have is this one. So that, okay, let's try to calculate this. 2 sine x times cosine. In this case, I just expand the inside one. 2kx plus x goes to be sine. We add those two, which is x plus 2kx plus x. And then plus, right? Plus sine x minus 2kx minus x. This is so-called identity, right? I can use this result here. Then your numerator goes to sine of 2kx. There is t here. Then instead of this, yeah, I write this length, which is sine of 2kx plus 2x plus sine of minus 2kx, because x and x is going away, over 2 sine x. And then the next identity I use is sine minus a equals to be negative sine a, right? So that I convert this one into the minus. Then sine of 2kx plus sine of 2 of k plus 1 of x minus sine 2kx over 2 sine x, and this one is cancelled each other. So we have the answer to sine x, then sine of 2 of k plus 1 of x. This is your right hand side of pk plus 1. That's why pk plus 1 is also true. After that, you can write, okay, consequently, your conclusion is there. So, okay, overall, what I can say is from here to there, it's easy, right? You just bring this one to there, and then we have one more term, right? After that, from this line to here is so-called the identity, trigo identity. Trigo identity question. We have the answer. This is the answer we need to get at the end. And then this is what we have at this moment. So then we go for the simplify process using the trigonometry identities, right? In this case, we have used these identities. Actually, this is one of the most frequently used identity in the trigonometry mathematical induction questions. You better to write all the rest three identities by just subtracting or the adding cosine with cosine and subtracting cosine with cosine. Yeah, you can drive three other identities. Anyway, yeah, this is the way. This is a typical example of trigo identity question. See, this is 12 mark already. Then another question can be just so-called complex. See, this one is very similar, right? With the cosine x question. It's almost the same. And then see, also this is very similar with the just before this cosine x plus cosine 3x plus blah blah question. There are not so many questions. You just exercise a few different types of the induction questions, so then there should be entire thing. Yeah, you can cover entire thing. The complex number with the mathematical induction. Yeah, I don't have much example, but anyway, this is the one of the previous past paper question about the mathematical induction with the complex number. Use mathematical induction to prove that blah blah. Always the same. The first line is let your Pn to be cosine theta minus I sine theta to the power of n goes to be cosine n theta minus I sine n theta. And then n is any positive integer. When n goes to be 1, your left hand side is just cosine theta minus I sine theta to the power of 1 is cosine theta minus I sine theta. Then your right hand side, cosine of 1 times theta minus I sine of 1 times theta, which is cosine theta minus I sine theta. Since your left hand side and right hand side is equal, it's always the same, right? P1 is true. After that, assuming your pk is true, which means cosine theta minus I sine theta, I rewrite this, I sine theta to the power of k must be the same with cosine k theta minus I sine k theta, right? To prove pk plus 1, left hand side goes to be cosine theta minus I sine theta to the power of k plus 1, right? And then if you compare this line with the left hand side of the pk, yeah, we have plus 1 here, which means we multiply one more times, so that what you can say here is cosine theta minus I sine theta to the power of k times cosine theta minus I sine theta. And then we know this much is there, right? So we bring that up. That is cosine of k theta minus I sine of k theta times cosine theta minus I sine theta. After that, we expand this. Cosine k theta times cosine theta minus, I want to multiply these two, right? I and I minus 1 minus 3 minus, so that there is minus sine k theta sine theta. This is the real part plus I. Now, yeah, I want to calculate the imaginary parts. Plus I, no, instead of plus I just put all the minus, because even, yeah, I will multiply this one, those two, minus I is there, I multiply this, minus I is there. All the rest is positive, so that's sine k theta cosine theta plus cosine k theta sine theta. Then it goes to cosine, cosine, sine, sine, comma, cc. Yeah, that is cosine A plus B, right? Cosine k theta plus theta minus I. C codo consider sine A plus B, right? K theta plus theta. Then I can say cosine of k plus 1 theta minus I sine of k plus 1 theta. There's your right hand side. That's why your pk plus 1 is also true. And then you should write your conclusion. You should write your conclusion here. Okay. I put one more example. Okay, the last one is pure derivative question, which is something like this one, 257. Okay, this is the derivative induction question. Again, the first step is let Pn to be dny over dx to the power of n goes to n3 m minus 1 e to the power of 3x plus x times 3 to the power of n e to the power of 3x. When n is 1, always the same process. Your left hand side is dy over dx, which is the dx of your y, which is x e to the power of 3x, while we have what product, so that derivative as it is plus as it is derivative, and then we better to match this one with this shape, so that there is 1 times 3 to the power of 1 minus 1 times e to the power of 3x plus x times 3 to the power of 1 times e to the power of 3x. That is your right hand side. That's why your P1 is true, right? Then again the same, assuming pk is true, which means dk of y dxk goes to be k times 3 to the power of k minus 1 e to the power of 3k 3x, sorry, plus x times 3 to the power of k times e to the power of 3x, right? To prove pk plus 1, then left hand side goes to be, yeah, k plus first time derivative of y, which is, I said previously that this is most important process for the induction, the derivative induction. This is one more step derivative of k derivative, right? And then we can bring this from here. Then d dx of k3k minus 1 e to the power of 3x plus x times 3 to the power of k times e to the power of 3x. Okay, we need to go for one more derivative. If we watch, we look carefully about the first term, then this much doesn't have any x, right? And then we go for derivative with x, so that we do just derivative of e to the power of 3x only. K times 3k minus 1. Yeah, we just leave those as a coefficient, and then 3 times e to the power of x. So this much is the derivative of this part, right? And then plus 3 to the power of k is just coefficient, just we leave as it is, and then this is product with the x and e to the power of 3x, right? So that derivative and then, sorry, derivative times as it is plus as it is times derivative. All right, and then we expand those two. K times e to the power, 3 to the power of k minus 1 times 3. Times 3 is 3 to the power of k, right? So if we rewrite this, then 3 to the power of k e to the power of 3x plus 3 to the power of k e to the power of 3x plus x times 3 to the power of k and then 1, which is k plus 1, right? 3x. And then these and these we can merge with 3 to the power of k and then e to the power of 3x, which is k plus 1, 3 to the power of k e to the power of 3x plus x times 3 to the power of k plus 1 and then e to the power of 3x. Then instead of this k, yeah, we can put k plus 1 minus 1. Right? Then this is the right hand side. That's why pk plus 1 is true. And then you can see you need to write the conclusion here. So the difference, the difficulty on those kind of question is, okay, the expression goes to be a bit complicated, especially if the product rule or the quotient rule is even more complicated, right? Yeah. But what you need to do is just precisely calculate the derivative. Don't forget we are doing the derivative with respect to x only, so that k is constant at this moment. Okay, of course, most important process step is this one. The k plus first derivative of function is one more derivative of k derivative of certain function. Okay, yeah, okay, up to here today. Yeah, so I can say, I won't say I have finished all the mathematical induction by this video, and then next time, yeah, I will come back with another topic. And then sorry, this week I including this one, I have uploaded only 2 videos because I was not really well at the very beginning of this week, and then the later part of this week, yeah, I was really busy. Tomorrow, yeah, even more busy. The Sunday is the horrible day for me, so maybe I'll be back on next Monday. Okay, see you on next Monday. Bye.